And welcome to the Martha's Vineyard Book Festival. We're very excited to have you here. And we have what I think is probably the most exciting panel. Before we talk about the panel, we want to note that the book festival is free, but we welcome and need donations. You can make donations at the information table in the front, where for $20 you get a great bag. Karen Sealander is holding the bags in the back. $20 per bag, pretty good deal. We also want to encourage you to buy the author's books today and not online. This is how we support the festival and the authors and the local bookstores. So let's talk about the panel. The panel is U.S. Government in Science, and we're pleased to have Peter Brannen, David Foster, and Sharon Weinberger, moderated by Ann Gibbons. Ann is a correspondent for Science magazine, where she has specialized in writing about evolution for more than a decade. She is the author of The First Human, The Race to Discover Our Earliest Ancestors, and a former Martha's Vineyard Book Festival author. She has a Knight Science Journalism Fellow at MIT and a Science Journalism Fellow at the Marine Biological Laboratory at Woods Hole. The panelists will take questions at the end of the discussion, and those who wish to ask questions will have a mic around here somewhere we can hand out. And after the session's over, all the authors will be signing books in the Menemsha room, which is immediately outside the door and to the right, for about 30 minutes. And with that, we would like to kick off the session, and Ann, if you'll take it away.
That's great. So we have a really big topic for 1 hour, science and government. So we decided among us to try to focus that on what science can do, what's the proper role, and what can it do to help solve some of the really difficult problems that are discussed in these books. Climate change, global problem. The weapons race, global problem. That would be Sharon. Erosion of our shorelines here on the Vineyard, that's a nice local problem. What can science and technology and government do to help address those kinds of problems? Especially important, I think, to have this discussion at a time when our federal government, our president, is threatening to cut funding to cut the EPA, cut funding in the Energy Department, cut the research that would lead to solutions. So we need to have these conversations and remind ourselves why this is important. I'm not going to go into it anymore, rather than introduce the speakers, and then I will ask them a few questions to get the discussion going, and then we welcome your questions. So the speakers are each going to describe their book and the topic in a short, very briefly, 3 to 5 minutes, and then we'll get to questions. So I think we'll just go right down the row in order. Is that all right with you guys? We'll start with Sharon Weinberger, and she is, let me get my notes here. Sharon is the executive editor for News at Foreign Policy and a global fellow at the Woodrow Wilson International Center for Scholars in Washington. Before that, she was security editor at The Intercept and author of Imaginary Weapons, A Journey Through the Pentagon Scientific Underworld. She has held fellowships at the Radcliffe Institute for Advanced Study at Harvard. Bear with me, she has a half dozen amazing fellowships. The Woodrow Wilson International Center for Scholars, MIT's Knight Science Journalism Fellowship. She also was at the International Reporting Program at Johns Hopkins School for Advanced International Studies, and she has written on military science and technology for Nature, Discover, Slate, Wired, The Washington Post, BBC, and others. And her book is a really interesting exploration of this agency, Darpa, that she'll tell you about. That's her main character. So
do you want me just for a couple minutes to talk?
Just a couple minutes. Tell us about your book, and maybe get, if you can, to why it's important to have government funding science and innovation.
Sure. So as Ann sort of alluded to, most of my professional career in journalism has been writing about the intersection of science and technology and national security. And most importantly, the question of how does science differ in what I call the national security state? That the goals of the national security community, which fund science, and they do fund a great deal of science, are different than the goals of the National Science Foundation or the National Institutes of Health. The military and the Pentagon prosecutes and wages war. So when it funds science, it's looking whether in the short, medium, or long term to fund things that help it wage war or keep the peace as it might be. So this book, which is a history of a very special agency called the Defense Advanced Research Projects Agency, is a broad look at this question of science and the national security state. DARPA, as the acronym is, was founded in 1958 in response to the Soviet Union's launch of Sputnik, the first artificial satellite, which was, for its era, a sort of 9/11 moment. It represented psychologically, although perhaps a bit erroneously, that the Soviets were well ahead in the space race, which is a little bit debatable. They did get to space first. But more importantly, the science and technology to launch a satellite was linked to the technology to launch an intercontinental ballistic missile. And so the resulting launch shook up the national security community and led President Dwight Eisenhower to authorize an agency that would, quote, create the vast weapons systems of the future, or as another science advisor to government called it, the unimagined weapons of the future. So what I did was to track the history of this agency and what it was supposed to do originally to why it became arguably the world's most successful science agency, science funding agency, or at least definitely the world's most successful military science agency. And a lot of what I look at is, today the things that we associate with DARPA, and it's an esoteric subject for some, for those involved in science and technology, it's very well known. But the internet is a direct result of ARPANET, which was created by DARPA to link computer networks. The drones that we see used in Afghanistan, Iraq, and elsewhere are a direct descendant of the drone programs that DARPA funded in the 1970s and 1980s. Precision weapons, stealth aircraft, even the Siri app on your iPhone all come quite directly from DARPA and DARPA's funding. So what I look at in the book is both sides of this legacy, both of the successes, and certainly the internet out of ARPANET was DARPA's most distinctive success. But what I argue is that the price of great success is also great failure. And so a great deal of the book looks at sort of a hidden or unknown history of DARPA, which was its very highly classified work in the Vietnam War in counterinsurgency. And most importantly, this concept of a global counterinsurgency strategy, a time in the 1960s and 1970s when DARPA was opening offices around the world from Panama to Iran to see if we could create a science out of counterinsurgency. As we now know, its legacy in Vietnam was not a good one, it was a failure. And so a lot of what I look at is, so are the successes, if you want to argue that this is a great research agency and you point to something like the internet, you also have to look at its greatest failures, which were the introduction of chemical defoliation into Vietnam, now known under the nomenclature Agent Orange, mass resettlement. It was a big proponent and an agent of the Strategic Hamlet program and other of these failed programs, which goes back to the central question of, is science in the national security state a good thing?
Excellent. So we'll come back to that topic. I'm going to introduce David Foster. And David is an ecologist on the faculty at Harvard University in biology. He's also director of the 4,000-acre Harvard Forest in Petersham,
Right.
that's how you say it, Massachusetts. He's conducted studies in the boreal forests of Labrador, Sweden, and Norway, and the forests of Puerto Rico, the Yucatan, and Patagonia, in addition to his primary research on landscape dynamics in New England. His main focus is on understanding the changes in forest ecosystems that result from human and natural disturbance, and applying these results to the conservation and management of natural and cultural landscapes. He currently serves on the boards of the Nature Conservancy, the Trustees of Reservations, Choate Rosemary Hall, and the Highstead Foundation, and he divides his time between Petersham and West Tisbury. And his book is a beautiful exploration of the natural history of this island and the challenges we're facing. So he will talk about that.
Thanks very much. So the world is facing incredible environmental challenges, and there's a need to bring as much information and as much perspective today and from the past to those types of challenges. And so the institute that I run, the Harvard Forest, tries to do that not at a global level, but at a regional, local, and even landscape level across New England, across the eastern U.S., and in some of these other parts of the world. We've been studying the island of Martha's Vineyard as part of that New England work, along with all the other coastal landscapes in New England for about 20 years. And I decided to bring all this information together to address the vineyard really for for three reasons. If one looks at the southern coastal region, the vineyard is kind of the quintessential example of this glacially formed world. It has the greatest diversity, some of the greatest scientific and historical understanding, and some of the greatest achievement in terms of conservation. So it's a wonderful laboratory to work on. There have been tremendous histories of the vineyard, histories of social systems, of religion, of military, of people, and genealogy. There has, and this is my reason number one, there has never been a history of the land, of the island as a landscape and how it's been transformed by nature and by people. Number two is we need an opportunity to take all of this information and chart a future for the vineyard that is a ecologically sound one. We have a remarkable history of conservation achievement. There's a tremendous need for more, both in terms of kinds of historical processes like the development of housing and so on, those kinds of pressures, coupled with the new pressure of climate change. But then three, the vineyard in many ways provides a microcosm for study and understanding and action that can both be applied to the rest of New England and can learn from other New England landscapes. And so the book really looks towards that future and tries to lay out some directions and some approaches for thinking that can work well on the vineyard, be applied elsewhere, but also incorporate lessons from many other places.
Great. And our third speaker, some of you might recognize from his days on the Vineyard Gazette here in Eggertown, where he got started in his career. That's Peter Brannen. He is an award-winning science journalist whose work has appeared in the New York Times, The Atlantic, The Washington Post, Wired, Aeon, The Boston Globe, Slate, and The Guardian, among others. He was a 2015 journalist in residence at Duke University's National Evolutionary Synthesis Center and a 2011 Ocean Science Journalism Fellow at Woods Hole Oceanographic Institution. And as I said, he got his start here at the Vineyard Gazette, and his book is about the 5 major mass extinctions in Earth's history, and it was just published in June, and it is gives us a sense of what we might be facing with global climate change. So he will talk about his book.
Yeah, so my book is about basically the 5 worst things that have ever happened in the last 500 million years or so. These are events where over 75% of life on Earth goes extinct in a geologically brief period of time. And really only in the past few decades have scientists been putting the pieces together of what has exactly gone wrong. So echoing what David said, sort of studying these deep time perspectives to give us some insight into what we might be facing in the future. We study Earth history sort of not only to tell us where we came from, to put our existence as a species in this big picture perspective of our place in the universe and the world, but we also study Earth's history to find out where we might be going. And so there's an entire field of geology called paleoclimatology, where it's the study of ancient climates. And in particular, there's this sort of urgent need to find a good analog in Earth's history for where we might be headed in the future. And so carbon dioxide-driven global warming is actually an experiment the planet has run before. And so it's kind of interesting that we can look at these past events and sort of read the tea leaves and see whether these events have anything to do with our future. So for instance, we know that past sea level has gone up by 30 to 60 feet for each 1 degree C of warming. So a study that came out earlier this year by a Columbia paleoclimatologist found that the last time it was 1 degree C warmer than pre-industrial temperatures, so before 1850. So what we're at now, sea level was 30 feet higher than it is today. So maybe we have that much sea level rise baked in. It's not quite clear. 36 million years ago, when it was 4 to 5 degrees C warmer than it is today, sea level was hundreds of feet higher. There was no ice in Antarctica or the Arctic. obviously, this isn't going to happen. So 4 to 5 degrees C is about where we're headed in a business as usual scenario by the end of the century. Obviously, sea level wouldn't go up that much that quickly because it takes a long time for ice sheets to disintegrate. But in the long term, we might, in the next few generations, really be turning this into a planet that it hasn't been in, really into deep geological time. You'd have to go back 36 to 50 million years ago to approach the same temperatures and carbon dioxide levels in the air. And the most concerning thing, and sort of what a large part of my book is about, is that there's been this revelation sort of that a lot of mass extinctions in Earth's history are associated with these really rapid, really huge injections of carbon dioxide into the atmosphere that's driven by these apocalyptic volcanoes that happen in different parts of the world. So one of them is the Palisades in New York, you might recognize. These big cliffs made out of basalt is actually the magmatic plumbing of these huge eruptions that you can find these eruptions from Nova Scotia to Brazil to France to New York City. And they would have been capable of injecting tons of CO2 in the air. We can see from different records, whether it's the plant record or just the geochemistry of the rocks, that it gets warmer. There's ocean acidification just like there is today. These events happen on a really massive scale, and we're not there yet. So that's the encouraging thing. But we can sort of, I guess, draw the lesson that maybe we shouldn't be messing with these forces that, when they've been summoned before in Earth history, have really caused some major catastrophes. I guess the punchline of all this, and relating to the topic, is that paleoclimate research is funded in very large part by the US government, by the National Science Foundation in particular. Whenever you go to geology conferences, at the end, they'll inevitably thank the National Science Foundation. So we can either go into the next few centuries completely blindly and just, put our heads in the sand, or we can invest and learn from Earth's history about, the challenges we might be facing and whether there's anything we can do to avoid it.
So my first question is going to be for you, Peter, because I want to follow up on that. And one of the things I hear a lot as a science writer is climate change deniers often say, oh, our temperatures have fluctuated wildly in the past. We've had sea level rise. This is all a natural part of the planet. It bounces back. So what would Earth be like if we went to CO2 levels as high as 1,000 parts per million? And I guess right now we have about, 300 parts per million carbon dioxide? 400. Yeah. What would it be like to live on an Earth with those? Would we survive the kinds of changes that we're predicting?
Well, I think it's amusing when I hear that, because so you'll hear that from someone like Marco Rubio, who claims not to really know what the age of the Earth is, whether it's a few thousand years or a few billion years. And yet he'll take this incredibly deep time geological perspective on the climate, which is actually true. Yeah, it's been warmer before, and CO2's been higher. But if you really grapple with what that means, so if we, in the Eocene, for instance, as far as we know, CO2 was around 1,000 parts per million, and there were palm trees in Alaska, and there were alligators in the Arctic Circle. And so, yeah, life was happy. There wasn't a mass extinction. But if you map that climate onto anything like today's highly networked civilization and inflict that change really quickly, could society, adapt quickly enough to that sort of really intense change? I think that's an open question. Life might be, in the past when climate changes, when you don't, in some warming events, life migrates to the poles. It actually shrinks sometimes to more efficiently cool. So life can adapt to warming episodes, but whether or not our civilization could, in an extreme warming scenario, I think is an open question.
Well, one of the things you write, just to stick with this for one more question, is you quote a guy at Penn State, Lee Kump, as saying, the rate at which we are injecting CO2 in the atmosphere is 10 times faster than it was during the end Permian, which was the worst extinction. And rates matter. We're creating a very difficult environment for life to adapt, and we're imposing the change maybe 10 times faster than the worst offense in Earth's history. That's the take-home message. And maybe you and then Dave could address that. Are the changes coming so rapidly? My understanding, it's the pace at which we're putting the carbon dioxide into the atmosphere that is unprecedented. And that rate doesn't allow many organisms to adapt rapidly.
Yeah, so for certain things, like carbonate chemistry of the ocean, which sounds like this dry topic, but actually could have these huge biological effects by the end of the century. So when you inject CO2 into the air, excess CO2, it reacts with seawater to make it more difficult for a lot of life to build their skeletons in the ocean. So some kinds of plankton and bivalves and clams and oysters, things we like to eat. And coral reefs build their skeletons out of carbonate. And when you inject a ton of CO2 into the air, it acidifies the ocean. It does a lot of things that make it more difficult for those things to stay around. And based on just business as usual scenarios, coral reefs, which host 25% of the ocean's biodiversity, are pretty screwed after mid-century or so. And so in a lot of these mass extinctions, you see reef collapses. And those mass extinctions played out over thousands of years. For the most part, and we could do in the next 50 years, what Earth has only done a few times in its entire geological history. So we really need to get a handle on our energy system, and quickly. So I guess that would be the take-home message, and the government is largely an engine for that, I would say.
So I want to keep establishing the problem a little, then we'll get to solutions. So Dave, you talk about in your beautiful book that Martha's Vineyard is disappearing. Our South Shore beaches roll inland 3 to 5 feet every year, which is one of the fastest, 3 to 5 feet every year, which is one of the fastest rates on the eastern seaboard. And in addition to that, we're talking about, well, let's just stick with that. My question for you is, what is the impact of that? And then I want to start getting into what are we doing, what can we do? What's a smart way to proceed to try to live with that? I'm not sure we can stop it.
Right, so
And that's also a result of sea level rise too, right? Erosion and sea level rise from climate
right, so
change.
the island and the rest of the coastal landscape was deposited about 20,000 years ago. At that point, these land masses were actually on dry ground. And the ocean shore was 50 miles south of where we are today. Over the last 22,000 years, there's been a progressive sea level rise, which is increasing now because of climate change and melting of ice sheets and all. But it has led to a continual loss of land that about 5,000 years ago resulted in the island formation of Martha's Vineyard and Nantucket as they became isolated from the rest of the landmass. So that's an ongoing process, and the question is kind of how do we understand that and how do we deal with it? So morphing into the second point, and I would make 2 points. The first is that we need to use that kind of historical perspective that I've just provided to understand the process. And it turns out that by the 1880s, and then published in the early 1890s, work by a gentleman who lived on Martha's Vineyard named Henry Whiting, who worked for the U.S. Coast Survey, and one of his colleagues laid out exactly this whole history and the rate at which Martha's Vineyard was shrinking in his time. And his map and his understanding fit squarely with our current understanding and our current estimates of the rate of change. And so for more than 100 years, we've had the scientific information to know where to build houses and where not to build houses. But remarkably, the local planning boards, the local conservation commissions, the Martha's Vineyard Commission, even many scientists have forgotten that kind of historical research. If we understand, though, the history of these processes, we can understand where we are in them and to anticipate the future, as Peter's been saying. But then the key point is to find the place in the process to attack the problem. And so if you think of fires or hurricanes or sea level rise or pests and pathogen outbreaks that are killing our trees, the solution is not to go out and to try to put barriers on our coast. It's not to go out and cut trees because they're dying or to spray them with chemicals. That's just dealing with the manifestation of the problem. The issue is to find out What's generating that problem? Well, for insects, it's their introduction into the United States. So if Donald Trump or anyone else wants to build a wall, the wall to build is not human immigrants, it's for insect immigrants, and that can be done, unlike the other one.
Insect ban.
For the coast, the solution is not to build this barrier, it's to understand how the process is working and to build appropriately, and then to attack climate change, which is exacerbating the problem. For hurricanes, for fires, and so on. The thing that we need to understand is that nature can cope with all of these changes. It's the human values that we put on these changes in our attempt to kind of get in there and provide immediate solutions at the point of the problem rather than at the point of the cause of the problem that leads to failed solutions.
So David, at a local level, we have, you said that 40% of the island is under conservation, but it's not, it's sort of a patchwork quilt. It's not a very organized, linked network of conserved land. But we also do have a great strength on this island of having a half dozen agencies, nonprofits like the Trustees of Reservations, the Land Bank, Vineyard Conservation Society, Sheriff's Meadow, Nature Conservancy, all working here to conserve some of the land. Is that one of our strengths? How do we proceed? What are the ways we go to, as we've got an eroding landmass, we have a pressure to develop, we have introduced species. How do we move forward? You know, I think of this island as a microcosm and also a model in many ways because we have a lot of resources. But what would you suggest? And then we'll come to sort of national means through Sharon.
So that's a perfect question for these times. It is a perfect question for the panel, and it ties in very, very well with Peter's book and some of what he's just talked about. New England is a world leader in advancing conservation, land protection, to protect land, farms, wetlands, forests from development. Martha's Vineyard is at the forefront of advancing that. There are these land banks, the Vineyard Conservation Society, Sheriff's Meadow Foundation, the Trustees of Reservations, Massachusetts Audubon, the Nature Conservancy, the state, the land bank, all working to conserve the land. We've got 40%. That actually, the numbers break down. 30% of the vineyard is developed, 40% is conserved, 30% is, quote, up for grabs. Well, it turns out that addressing that is figuring out a way to advance land protection today in a way that matches what has happened in the past, is actually our local solution to these global problems. Because it is the removal of forests and the undermining of natural vegetation and all, which is one of the great sources of both releasing carbon dioxide to the atmosphere, and one of the great solutions, because as forests grow, they take carbon dioxide out of the atmosphere and they store it. And so what New England should do broadly, and what Martha's Vineyard should do locally, is to figure out ways to keep nature intact. And that can be done while still accommodating levels of development that are appropriate for the landscapes that we're working with. And so there is a partnership of all of these organizations, admittedly, because I know this because the Edie Foundation, which is based on the island that I'm on the board of, and the conservation partnership of all these organizations have recently met. That partnership is no longer effectively advancing land protection, but there's a huge opportunity to do that. And so we're meeting now to see how we reach out to local landowners and how we find additional financial resources to augment what this phenomenal land bank is doing in terms of its conservation activities.
It's interesting because I think of places like New Orleans or Florida, and they, you know, this is a microcosm for the problems that will need to be solved in many places as sea level rises. So Sharon, you have a particularly good perspective on how the national government can help address the core problems. In this case, we're talking about environmental problems, climate change, but we can also broaden this to some other kinds of core problems, energy. For climate change, it's an energy problem, probably more than anything else, alternative energy, but also environmental management. So I'm wondering if you can address how the government can do that effectively. Do we develop a sort of ARPA, DARPA type model in the EPA? I hear that there is supposed to be an office like that. Do we develop, a lean, mean group, the task force that can go after these problems in federal agencies quickly and effectively? What do you think? How do we go?
I probably don't have a very optimistic answer for you. Let me start by actually talking about something that overlaps with what Peter was talking about. The first government funding for paleoclimate research in the United States was actually from DARPA back in the early 1970s. So a little sort of unknown history of not just DARPA, but climate research was in the early 1970s, DARPA started a very classified program originally called Nile Blue, which was looking exactly at that, at climate change, only the concerns were certainly not for the environment. The concerns were driven by the Cold War. The Soviet Union was looking at a lot of sort of very grandiose projects to dam the Bering Straits, to change the directions of rivers in Siberia, and this sparked a lot of concern in the Pentagon about what would be the impacts on climate. So they started this classified program. They brought a scientist in who immediately declassified it. He said we need the work in the universities and academic community, and started funding a lot of different areas, including paleoclimate research. This is before the National Science Foundation got involved. And DARPA basically laid the foundations for the first national climate research program, and then it got out of it because that's what DARPA does. It had a national security concern, it looked at it, it moved over to the National Science Foundation, and it moved on. Which leads to a second interesting part, that the Pentagon, although it's often thought of as sort of a conservative institution, there's no ambiguity about its position on climate change. It believes climate change is happening, and it is preparing for it. It doesn't have debates about skeptics or not skeptics. It takes it as a given. It's not involved in sort of the debates in the current administration. Now to get to the third part of the issue, though, of whether there could be an agency like DARPA, meaning instead of an innovative, no red tape, bureaucratic-free agency that could come up with solutions. Let me talk about why that's hard. DARPA is a problem-solving agency for the national security community. So in its early days, it was tasked to get America into space, to come up with protections against intercontinental ballistic missiles. That never worked very well. To come up with a way to detect Soviet nuclear tests. That worked very well. To look at what the Soviets were doing that could affect climate change. That worked very well. But there was always a customer for it, meaning the customer is the Pentagon. So, and the Pentagon has very deep pockets, and it has a lot of problems it needs to solve. That's a good combination, very deep pockets and problems that you need to solve. And DARPA, because of its successes over the years, there have been a lot of attempts to replicate it. So the Department of Homeland Security has a DARPA, which just failed dramatically. There were proposals many years going back and forth to fund an ARPA for energy. After many debates, that was funded, called ARPA-E, ARPA Energy. I think the Trump administration has proposed defunding it. And the problem with an ARPA for energy, which would incorporate things like alternative energy that could help with climate change, is that who is the customer for it? The Pentagon buys things. The question that people have always raised about ARPA for energy is, what is the transition path for these things that you're funding? And that's always been very ambiguous because it's not the Department of Energy. If it's private companies, how do you handle that trade-off? That's never been very well delineated. So that is the challenge. One of the things that you could do, when people have looked at DARPA in its current incarnation, previous directors, and sort of bemoaned its sort of fall from sort of excellence over the years. One of the things they said is, DARPA was formed for what was in 1958 the most important problem facing the nation, the Soviet Union, the arms race, the space race. So suppose you formed an agency for what is the most pressing problems today, which could be something like environmental change, and you got sort of all the best experts. I think that's an intriguing idea, but again, how something works is very, very important. So you have to think about, okay, what would this agency do? It would spend money. It would spend money on prototypes or solutions. And again, who is going to implement that? And without a clear path for how that would happen, I'm not sure that a sort of recreated DARPA for, be it in the environment, climate change, energy is going to be as successful as the original DARPA was.
So it may not be that we need as much the research and innovation here as figuring out how to implement what we already know. So, for example, Peter, you talked about how the government was very successful, international governments together, in preventing the ozone hole from destroying our protective layer of ozone across the entire atmosphere, because there are international regulations on chlorofluorocarbons, which is a relatively narrow industry. You talked in your book about why that's so much harder to do with greenhouse gases. Maybe you could talk about that briefly and what you think might have to happen to do that.
Yeah, I think chlorofluorocarbons, which people projected out to the 2060s, what would happen if we had a business as usual use of chlorofluorocarbons as a society, and the ozone layer all but disappears by about 2060. So, it would have been pretty bad. There would have been, skin cancer rates would have been off the charts and all sorts of bad things would have happened. But chlorofluorocarbons are kind of a pretty small sector of the economy, as you said. And as one paleoclimate guy told me, basically the entire project of civilization is to dig carbon out of the ground and burn it as fast as possible. So it's basically, that is, since the Industrial Revolution, that's basically underwritten all the, both the gains in society and a lot of the environmental excess. But it would require totally transforming our energy system rather than banning a niche industrial chemical. So I think that's why the carbon problem is so intractable.
So on that cheerful note, I'm going to open this up to questions. If anybody has questions for the speakers, this is your chance. So I'm looking for any questions. Oh my gosh, we just scared you all. Oh, good. Yeah, right there. Second, third row.
I feel as though you're all being very direct about what we're facing and at the same time holding back. I don't know, but it just feels a little bit like you're raising the very good point about, the military and funding through them. Meanwhile, there's the National Science Foundation, et cetera. But it just feels like you're holding back and maybe feeling we need to be protected from really taking in the massive things that you're talking about.
So I'll repeat the question.
That's the question. Right.
Are you guys holding back? Are you not telling us really how bad it'll be and what we need to do?
So I'm not sure if this is exactly where you're going, but if you look at the kind of enterprise that we, my institution, and our colleagues are involved in, so and this tie with the federal government and funding and so on. So funding is coming from the National Science Foundation, the Department of Energy, from the Forest Service, from NOAA, from NASA, from EPA, and from Darpa to all this enterprise. And the ability to assemble that information and what that provides us in terms of actionable science, actionable information that we can then apply to the problems that we are facing is just phenomenal. And it's leveraged in so many different ways by so many other sources of funding. And so on the face of it, this whole question of, kind of what's the link between the two and should the government be involved in this is a bit ridiculous, because of course the government should be involved in it, and there is very effective science coming out of it. We know what we need to do, and so what we're holding back from you at all is the need to continue that full bore and then to actually act on the science that is at hand. And we've heard panels earlier today where people have explained, and last night, where people have explained and explored all the reasons that we're not acting and that there aren't solid policies that are leading to that kind of action.
Well, in the absence of federal action, can the states and the local governments fill the gap? They're not going to be able to do enough, but it seems even more critical. Some states are certainly becoming leaders.
So we were talking about this last night having to do with issues that ranged from abortion rights to environmental problems. And it is very true that states, in some cases local governments, in some cases individuals and regions can make a huge difference. So there's every reason that that should happen. And one of the bright things that is happening in the current federal, under the current federal administration and in our modern times is the fact that it's galvanizing all these other layers of activity that might not have stepped forward.
Another question. Right behind the pillar?
Yeah, you hear a lot of arguments from climate deniers as to why there is no climate change, but you never hear why they actually believe that. Is there understanding like what motivates them, what their psychology is? Why just go through this asinine argument that just isn't true?
I don't think I need to repeat that. You can all hear, right? Wants to take that.
Well, I think it's the product of a big tobacco-like disinformation campaign that's been very successful. The same way that you had doctors on advertising cigarettes in the, 50s and 60s, just completely ludicrous positions that nevertheless people were willing to believe. The conversation within the science community is so far beyond what you hear in the, public discussion. It's just amazing. In 1862, Irish physicist John Tyndall discovered that carbon dioxide was a greenhouse gas, and in 1896, the Swedish physicist named Svante Arrhenius did a back-of-the-napkin calculation that if you doubled CO2, temperature would go up about 4 degrees, which is roughly in line with what our supercomputers tell us. And there was some op-ed in the New York Times in the 19-teens about how if we burn all our coal, the planet might get uninhabitably hot. So we've had a pretty good handle on just the basic physics of climate change for a long time. And yeah, I'm as flummoxed as you are of how it's been as successful as it is at misinforming as many people as it has. So.
You did say in your book that when scientists go out for a drink with you, they always say we're screwed. Is that the verb, or was it another one?
Yeah, no, it was a different word, a little more colorful word.
Yes.
But,
Could I add just two things?
Of course,
Sarah?
please do.
Yeah.
I think one, and I'm not the expert on this, you'd have to look back at why it's been politicized in some sectors. So from my little world of looking at national security, you certainly meet a range of political views in the Pentagon and national security community, very, very conservative and liberal as well. I've never met a climate denier who works in or around the Pentagon on relevant issues, or if they are, it's not something they feel the need to voice on. It's not a politicized issue within the national security community.
I saw a question right over there. Yes, and then over there.
Yes, I am Martha. I'm trying to save some ponds around here, and I've been, since this is a book festival, I would like to ask the panel, what can the effect of fictional books and scientific books, where can we really find the strength to rally the public and readers around this? What is the potential of books for this, for affecting change?
Well, with so many of these issues, even take the very local issue of conserving and protecting land, you're really talking about reaching individuals, right? If an effort, for example, on Martha's Vineyard is going to be successful to advance land protection as it has in the past, it's going to be because the individuals who vote and the individuals who own land are convinced to act. And so there are many different ways to reach people. And there are many different forms of media that reach people. And so without a doubt, the written word, whether it is fiction or nonfiction, can be really powerful ways to advance that kind of action. And that action can grow. And that would be my response, that the more we can try in as many different ways to reach this audience of actors, the more successful we'll be.
So I would just say that I was told that climate change books don't sell. Most people just think they're too gloomy and they don't want to read them. And so as depressing as I've been so far, a lot of my book is not like that. It's
Nice try.
I kind of yeah, there's some jokes, but also
That's his agent in the back who's telling him to be optimistic.
Yes, exactly.
because it's such a politically charged issue, I kind of took this not strategy, but like a lot of my book is describing ancient worlds, and everyone loves dinosaurs, and so it's very much a book about natural history and all these alien planets that, for the most part, you don't learn about when you're in school. And so that's kind of the Trojan horse to start to introduce people to, and then there are also these climate disasters, and because everyone likes reading about dinosaurs, and there are all sorts of stories from Earth history that are interesting and that aren't politically charged, and it's sort of this arena outside of politics. So that was sort of my strategy, and yeah, I tried to excite the same reason people get excited for science fiction, basically, because the planet has been so many different planets over its lifetime, but can also teach us things about the modern world and where we're going.
These are really compelling books. I know because I read them all this week. So you had a question.
I
We're
have
waiting
a
on you.
different kind of question. So don't usually get to talk with people like you, so I'm curious about the pipeline issues, and particularly around whether anyone's concerned about STEM in the education world, and where you're going to get the next people to either even understand what's in your books, or I'm more curious, Sharon, about ARPA Ed that never went anywhere. And, I don't know how you all can help raise the awareness of the fact that there's really almost no money. I mean, if we're lucky, the House budget will give NSF maybe will only be down by 2%, the Senate more. But there's almost no money that is now in the Department of Ed that's for STEM education anymore. That's been removed. And, and NSF is the one directorate has very little. So it's just a huge concern. And I never hear anything very much about it. So I'm just wondering, as writers and journalists, if there's a way to push this
So Sharon,
argument.
why don't you start with the idea? Do you know anything about the education ed at Darpa?
Well,
ARPA Ed?
Yeah, I'm very skeptical of most of the plans for ARPA for education. I'm not a STEM expert, but let me take it from a little bit of a broader perspective. And I mean, not that I'm trying to sell myself as an optimist, but I tell people to take a broader view about government funding of science. I know there's a lot of concerns now about the cutbacks, and those are legitimate concerns. I'm concerned too. But a lot of the history of DARPA is about a Cold War history of science. And the very idea of government funding of science and what sort of science it should fund is A, somewhat new to post-World War II, and B, it has gone through ups and downs with the bubble in physics, what we funded in different eras and the height during Ronald Reagan. I think what we're seeing now is a revisiting of that debate unfortunately, it's not a very informed debate right now on the side of government of what sort of programs should be funded. So we're seeing proposed cuts to the National Institutes of Health, National Science Foundation. I'm very concerned about that. If the Defense Department budget goes up, what has traditionally happened is science and technology funding under the Defense Department goes up. DARPA will benefit. Is that a good thing? Is that a bad thing? It depends on how you look at DARPA's legacy. But I think there has to be some depth to the debate, not simply that budget cuts are good or bad, but what is the government trying to do? What concerns me more right now in the current administration, because I think a lot of their budget cuts won't survive anyway in Congress. So I'm actually not as concerned about that. And frankly, if it goes up or down a little bit, more likely down, I don't think that's the end of the world. I am much more concerned about the fact that there are literally no scientists in the White House, that for the first time, there's the Presidential Science Advisor, the Office of Science and Technology Policy, the federally funded research and development centers, the FFRDCs, which are, have funding, are not being tasked to do anything. They're sort of ghost ships at sea. That is very concerning. That concerns me much more than the cuts up or down, because those can be rectified fairly easily in subsequent years. The emptying out of knowledge within the government is something that will have much longer term impacts.
I can't read that sign in the back. Is that the 5-minute warning or the end?
One more question, I think we're done.
Hi.
Okay, thank you. I couldn't quite read.
The woman in front of me who asked the question before about urgency, I don't think this is a lovely panel of thoughtful people talking to a room of people who are already convinced, and you're using words like flummoxed, and, we'll try and use the Trojan horse of the dinosaurs, and so for some of us, it's similar to the tobacco situation, I find it unnerving and very scary that until the last moment when you were talking about the fact that there are no scientists in the White House, and that scares you, that if you people are going out to talk about your books and these subjects in these wonderfully controlled tones, we're in really serious trouble here.
So do you have a question? I agree with you, but do we have a question? Should they sound the alarm more? Is that your question?
I think the question is, in a sense, why do you seem so fearful of sounding the alarm more?
Oh, you should read what we write.
No,
seriously, you should read what we
I'm
write.
not your audience. It's non-readers.
You should read what we write, and you should listen to what we actually say, because the reason that I go to forums and talk, and the reason that I write in a way that is engaging a broader audience outside of the science, is because I actually see the imperative that you're talking about. And I spend at least as much time in my life trying to apply that science by engaging these local landowners and all the rest. So I think we are reserved here, but I don't think I think that just covers the passion that's inside that we share very regularly.
These are very passionate books, I will say that, and they are trying to speak to a broad audience. We are all converts already. Thank you. Thanks, guys.
Just a reminder, first of all, thank you.